you to do the expected values, and this is how you kind of set it up in order to do the chi-square. Now you'll see on number 11 that now we're going to do a test for heterogeneity. So again, we're going to do our contingency tables. You can see that on the back here. It's got a contingency table set up for you.
Can you go back to the page? What's this stuff on the right? On the expected?
This right here.
Yes.
That's just...
Did we type that in, or
No.
expected?
No. So all you type in is this right here, and then this is just extra junk that it gives you that we don't care about for this part. So remember when you did your test for heterogeneity, it also gave you a bunch of other junk. So here, this also gives you like a bunch of junk down here. For the purposes of this, we do not care about that. All we care about is, so this is your heterogeneity test. All we care about is the chi-squared, the degrees of freedom, and the p-value. That's all we care about. I'm sure all that other junk is really, really exciting to somebody, but we don't care about it. Okay, so now we're going to do our chi-square test for heterogeneity, again, on our same individuals. But now we're going to make it into a contingency table. So again, we want to do, we're going to be summing this up in a slightly different manner. So you're going to end up having 5 of these tables, and that's just a copied table from right here. These are your contingency tables. You'll have 1 for each. Okay? So for our water penny example, all this means is sticks/stones. So instead of sticks, this should actually be macrophyte far. Remember, we didn't actually do sticks, we did the macrophytes instead. So forget the sticks, that should be macrophytes. /stones. So all that is saying is that these are considered a grouped microhabitat. Okay? So the macrophyte far is analogous to the stone. The macrophyte edge, or macrophyte near, is considered analogous to the edge. And that's just because that's the way we set up the contingency table. And then water column is obviously water column. Okay? So now what we want to do is we want to total up the number of individuals in each of the microhabitats, again, based off of this table. So for, let's just use slow moving right now. So for slow moving, how many are in our macrophyte far? We have 0. And this is just for water pennies right now. Okay? So how many in our slow moving do we have at the macrophyte near/edge? 1. Goes right there. Open water column, again, we have 1. So that's how you do your contingency table. Again, for fast moving, how many water pennies do we have in our fast moving for stone? We've got 10. Goes right here. For macrophyte/edge, it's over there, but trust me, it's 0. And then our water column, we have 0. Okay? And so then what you want to do, this is again just for water pennies. You have to do this for all 4. What you want to do is create a graph based off of that. Okay? So, well, first, let's go back and review how to do the chi-square test for heterogeneity. So, we just did that real quick. Again, you're on this page, you go to clinical research calculators. Instead of goodness of fit, you'll see the contingency, the chi-square contingency table one. You click on that. Again, those instructions are also posted on Blackboard. And then this is the setup that you have, right? So you put in your number of columns, number of rows, 3 and 3. Oh, excuse me, 3 and 3. And then you put in your information from the contingency table. You copy it directly, hit calculate, and it's going to give you your chi-square value, degrees of freedom, and your p-value. Okay? Then all we want to do is we want to plot that. So then, again, you just highlight your graph, and then it's going to have stagnant pond versus open water. So these should be, these top ones here, which are your microhabitat comparisons, these should be your series, and then on your x-axis should be your habitats. Okay? Any questions? And so for this particular one, we did have the p-value, if you notice, was 0.002. Again, that was significant. So what can we say? That probably the sticks and stones in the fast-moving habitat pretty much threw that off, meaning that there are more individuals located in that habitat, or in that habitat. Okay? Any questions? I know that was a lot. So that's also part 12, the graphing, determine which species predominate in which habitat. So then you're going to have one of these for each of your contingency tables. And then you can see, if you compare them side by side, this is the water pen one, you can see where the water pendants predominate versus the damselfly larvae versus your snails, etc., etc.
So it's not in comparison with each other, it's with their comparison within their own microhabitat?
That is the comparison, but then you can look and kind of see where they're dominating. So then you can see that maybe your damselflies are over in the stagnant pond more, like there's more individuals over in the stagnant pond. Does that kind of make sense? Then you might have more snails in the slow-moving stream, so you can kind of just look at the graphs and compare graphs. Okay? Okay, so now, again, fill this chart out in the back if that helps you. It does help me, at least in trying to organize this data in my own mind, so hopefully it'll help you as well. As for the guidelines, let me grab this. We can go through this real quick. The middle section